Good morning, students. Today we are going to discuss about this experiment. It's an air bench. Using this experiment, we can able to determine the thickness of a thin wire. Right? And this is the air bench setup. Here you have a two glass plate setup. And in between the two glass plate, we kept our thin material is a hair. On the other end, it is tied with a rubber band. So because of the hair, there will be a wedge shape which is formed in between these two glass plates. And if you keep this air wedge, because of this hair, there is a wedge shape of air film will be formed in between the glass plate. So it's called air wedge. If you keep this air wedge setup behind this 45-degree tilted glass plate, the incident ray will fall on back side of the glass plate and it has to be sent to the air wedge setup normally. So that one part of the light will be reflected by the top glass plate and next part will travel through the air gap that will reach the bottom glass plate and that also reflect back. Now these two rays will superimpose on each other. We have the interference pattern. So first we have to focus the interference pattern with this setup. And before that, you know about this instrument. It's called traveling microscope. Why we have called this traveling microscope? Because this microscope can able to move along the vertical axis as well as horizontal axis. That's why we are saying it's a traveling microscope. In this microscope, we have to take two readings on each and every position. One is MSR and other one is VSC. Now I tell you how to find the reading on this instrument. See, here we have an horizontal scale. In this horizontal scale, there is a main scale and vernier scale. On your vernier scale, the first division which indicates a 0, that's called vernier 0. To find the MSR, just look at your vernier 0 alone, how much it is crossed over the main scale. How much completed value is called MSR. Then to find the VSC, we have 50 divisions on your vernier scale. Out of this 50 division, any one of the divisions should exactly coincide with the main scale division. So which one of vernier scale is coincide with the main scale? That will be your vernier scale coincidence. Okay? So that's the way to find the reading like MSR and VSC on your traveling microscope. Now we go to the experiment. So we have to focus the fringes first. So now we focus the fringes on this instrument. So we have the alternate bright and dark fringes. The bright fringe will correspond to the constructive interference and dark fringe is due to destructive interference. So here, using this pattern, we have to find out what is the bandwidth of the fringes. So bandwidth in sense is the distance between any consecutive bright or dark fringes. So to find that, we have a tabular column. In this tabular column, the first one thing will be the n, which means you have to consider on your crossfire, near your crossfire, consider any one of the dot line as a nth line at which focus your crossfire and find out what is the MSR and what is the VSC on your vernier scale. Just note down the reading on your tabular column. Note down the reading on your tabular column as a nth reading. Then, next we have to take a reading at n plus 5, which means after the nth dark fringe, we have to count 5 fringes. Just by rotating this screw, that traveling microscope will move towards this direction. So, by viewing through this eyepiece, we have to count 5 fringes. 1, 2, 3, 4, 5. So now I have the n plus 5th fringe on your field of view. Just we cross the coincide, focus your crossfire on the n plus 5th fringe and note it down what is the MSR and VSC. After that, just count it again for 5 more fringes. That will give you n plus 10. Similarly, take it out for n plus 15, 20, 25, 30, 35, 40 and so on. So this is our experimental setup. after that, we have to find the distance between the rubber band and the material. So now, I just remove the airbag setup from the glass plate. Just place it in front of the microscope. Just move the microscope to coincide the rubber band, and there you can find out what is the MSR and VSC. Just note it down, that is against R1, because the R1 is the reading of the microscope when the crosswire is along the edge of contact. Next, move the traveling microscope and coincide with the hair, then find out what is the reading of it, that is R2. Reading of the microscope when the crosswire is coincide with the wire. If you find the difference between these two, R1 and R2, that will give you the distance between the rubber band to hair. So in our experimental setup, we got it, it's like a nearly 3.099 centimeter. So from this we got L value, and from this tabular column we have to find the beta. How to find the beta? And these are all the total values of this readings. Using this total value, find out the width of 10 bands. The first one corresponds to the position of the nth band, and the third one corresponds to position of the n plus 10th band. So in between these two we have a 10 fringes. So if you find the difference between these two values, that will give you the width of 10 bands. Similarly, if you find the difference between the n plus 5 to n plus 15 on this total reading, it will give you the width of 10 bands. So by way, we have to find the width of 10 bands on each and every side, each and every position. From that width of 10 bands, we can find the width of one band, just divided by 10. After that, find the mean of all those values. It will give you the width of one band, its current beta. Using the beta and L value, substitute those values on this formula. The formula to find the thickness of the thin material, T is equal to L lambda by 2 beta, where L we got it as a difference between the edge of contact position and the material position. Beta is a fringe width. Lambda is a sodium lamp, is given wavelength, is a 5893 Armstrong unit. So by substituting all those values, you can able to calculate the width of the thin material, thickness of the thin material. That's it. Thank you, students.